Okie dokie. In this problem, again, we are evaluating the indefinite integral of some function. So we're finding the antiderivative of each of these pieces here. So in order to do so, we will start with a over z. So a over z is the same as a times 1 over z. We've talked about before, when we have just 1 over z or 1 over x or 1 over t, where on the bottom it's literally just that variable raised to the first power. There's no other exponent, whatever. 1 over the variable will always have an antiderivative of the natural log of that variable, specifically the absolute value of that variable. So we are looking, and then so that a coefficient will carry down into the antiderivative as well. So we are looking for a times ln of the absolute value of z. Right away, we can eliminate any options that don't have positive a ln of absolute value of z. So then we are looking at this term, plus b over z to the fourth. Anytime we have a variable raised to a different exponent in the bottom that's not 1, right? This will mean we are going to use the reverse power rule. How we do that is by bringing that term, z to the fourth, out of the denominator with the help of negative exponents. B over z to the fourth is equivalent to bz to the negative fourth. So this allows us to take the antiderivative by leaving the plus, leaving the b, leaving the z, but then adding 1 to its exponent. Negative 4 plus 1 is negative 3. And then we divide by that same exponent, negative 3. And so when we simplify this or rewrite this, we'll still have the a ln of absolute value of z. But then the negative from the 3 will kind of negate this addition to subtraction. And then the b will stay on top. And the z to the negative 3 will translate to z to the positive 3 in the denominator. And that 3 was already in the denominator, so it'll stay in the denominator. Oh, say, can you plus c? And that should be it. So we're looking for the minus b over 3z cubed, which looks like option B. All right, let's go and do a couple more, a little bit faster, hopefully. The first step is finding the antiderivative of c cosine of x. So c cosine of x, we will have c will stay. Cosine of x has an antiderivative of sine of x. If you did not see my one cycle derivative, antiderivative thing for sines and cosines, the red arrows indicate the cyclic nature of the derivatives of sine and cosine. The green arrows have the direction of the antiderivatives. And so in this case, I think we just found the antiderivative of cosine, and that turned out to be sine. So just, go back, take a screenshot of that, picture of that, whatever, to use going forward. It can be helpful. So antiderivative of cosine, again, is sine. So the c just stays out in front. And then the plus p over x, again, x to the first power in the denominator indicates we use ln of absolute value of x with the p out in front. So we're looking for two positive terms, so no negatives, no negatives, no negatives, no negatives. Oh, look at that. It's the only one with positive, so E must be our answer. All right, let's go and do one more. Oh, this is a great one. So no rewriting required. Wow, that's a tongue twister. All right. No rewriting required here, so we are just going to leave the coefficient, leave the z, add 1, the exponent to get 3, divide by that exponent, hit the plus, and then the r is the coefficient, and then e to the z has an antiderivative and a derivative of e to the z. So you got to see it, and that should be it. So we're looking for what looks like option B. All right. Hope this makes some sense. If you have any questions or any weird functions that you're being asked to take the antiderivatives of and you're having a little trouble, feel free to comment, let me know, or email it to me. Yeah, hope this helps.